All right, welcome. Have you ever really thought about what happens when you hit send on a Bitcoin payment? I mean, really thought about it? It's not just some number changing in an account somewhere. Today, we're going to dive deep under the hood and see exactly how a Bitcoin transaction is built piece by piece. So what is that journey? What's the life of a single payment? Well, it's this fascinating process of digital assembly. And believe it or not, it all starts with an idea that works a whole lot like the physical cash you might have in your wallet right now. And to make this super easy to follow, we're just going to tell a simple story. We've got Alice, and she wants to buy a podcast from Bob's online store using a little bit of Bitcoin. This one simple purchase is going to show us the entire structure of how a transaction works. Okay, so a transaction is born. Before Alice can send a single Satoshi, her wallet app first has to actually build the payment. And the very first step, kind of like reaching into your pocket for some cash, is finding the money to begin with. Which brings us to finding the digital coins. This gets at a really common misunderstanding. A Bitcoin wallet doesn't actually hold one single balance, like your bank account does. No, instead, it holds a whole collection of different pieces of digital money. Think of them like coins and bills of all different sizes. And this design, it's totally key to how Bitcoin works. And that brings us to the super important term UTXO. It stands for Unspent Transaction Output. Now, I know that sounds technical, but honestly, the easiest way to think of a UTXO is just as a specific digital coin or bill. Your total balance, it's really just the sum of all the different UTXOs your wallet has control over. That's it. The best way to picture this is the purse metaphor. So when Alice goes to pay, her wallet app doesn't just look at her total balance. It literally sifts through all the individual UTXOs it holds, just like you'd rummage through a purse looking for the right change. It grabs one or more of them that are big enough to cover the payment, and these chosen UTXOs, well, they become the inputs for this new transaction. Now, in our story, we'll keep it simple. Alice's wallet scans through her digital coins and finds one single UTXO that's worth more than the podcast she wants to buy. It's kind of like finding a $10 bill to pay for a $5 coffee. This one UTXO is all it's going to need. All right, so building the payment. The wallet has found the funds. Now it has to actually build the payment structure. And this is more than just sending the money. It's about locking it in a way that only one specific person can ever claim it. And it does this using a process called encumbering. Now, that's just a fancy word for locking the funds with a very specific condition. Her wallet creates this kind of digital puzzle that says, hey, this money can only be spent by the person who can provide a signature from Bob's public address. And since only Bob has the key to do that, that money is securely earmarked just for him. Pretty neat, right? Okay, hold on. Remember how Alice's UTXO, her digital $10 bill, was worth more than the podcast? What happens to the change? I mean, does it just disappear into the ether? No, of course not. The system has a really clever way of dealing with this. And the solution is actually remarkably simple. This single transaction creates two new outputs at the very same time. The first one is, of course, the payment that goes to Bob. And the second one is a brand new UTXO, the change, which gets sent right back to an address that Alice controls. It all happens in one single seamless operation. So we have the payment to Bob and the change back to Alice. We're all good, right? Well, not quite. What actually makes the whole network process this? What's the incentive? That's where the miners and their fee come into play. Yeah, think about it. We've accounted for the payment to Bob, and we've accounted for the change coming back to Alice, but there's no third output that says miner fee. So where does it come from? How does the miner who grabs this transaction and puts it in the blockchain actually collect their reward? And here is the really clever part. The fee isn't some separate line item. It's implied. It's just the little bit of digital dust that's left over after you subtract the outputs from the inputs. It's a brilliant piece of built-in accounting. Let's just look at the numbers here. So Alice's input UTXO was worth, say, 0.01 Bitcoin. The output to Bob was 0.005. Her wallet then creates a change output back to herself for just a tiny bit less than what's left over, maybe 0.0049. And that tiny amount that's left unaccounted for, that's the miner fee. And there it is, 0.0001 Bitcoin. That's the leftover amount. And any miner who picks up this transaction can claim that difference as their payment for doing the work of including it in the blockchain. It's simple, and it's super effective. So, let's recap. The transaction is fully assembled. It's got the inputs, it's got the outputs for the payment, and the change, and it's got that implied fee baked right in. It is now a complete, self-contained little package of data ready to be sent out into the world. Now, Alice's wallet doesn't send this to some central server or a bank. No, it broadcasts it out to a few computers or nodes on the Bitcoin peer-to-peer network. And then those nodes share it with other nodes, and they share it with others. And boom, it spreads across the entire globe in just a matter of seconds. And that's it. Really, that's the creation phase. Alice has done her part. Her transaction, which contains all the information anybody needs to verify it, is now zipping through the network, just waiting to be picked up. This really gets to the core of what makes Bitcoin so powerful. The transaction itself contains everything necessary to confirm ownership of the funds and assign new owners. It's its own proof. It doesn't need some outside bank or authority because all the proof is baked right into the data itself. So picture this. Alice's fully formed transaction is now floating out there in what's called the memory pool, this huge global sea of unconfirmed transactions. It's just waiting. But what is it waiting for? And who is going to be the one to finally find it and make it a permanent part of the Bitcoin story? Well, that is a topic for our next explainer.